Let us understand five different heat treatment processes. For each process, we'll have five simple questions. Why is it done? The purpose. How is the metal heated? Heating. How is it cooled? Cooling. What properties does it gain? The result. And where is it used? The applications. Let's start with annealing. The main purpose of annealing is to make the metal softer and relieve internal stresses. The metal is heated above its critical temperature and then it is cooled very slowly inside the furnace. Because of this slow cooling, the metal becomes soft, ductile, and easy to machine. That's why annealing is commonly used for sheets, wires, and forgings before further manufacturing. Now, the second heat treatment process is normalizing, and the metal is heated above its critical temperature. It's simply cooled in still air. As a result, the metal develops a finer grain structure, becomes stronger, and has more uniform mechanical properties than annealed steel. It's commonly used for gears, shafts, etc. Coming on to the third heat treatment process, which is hardening. The objective here is simple: maximum hardness and wear resistance. Again, the metal is heated above the critical temperature, but this time it's quenched rapidly in water, oil, or brine. Rapid cooling makes the metal very hard and wear resistant, but it also makes it brittle. That's why hardening is widely used for cutting tools, drills, dies, and bearings. Coming on to the fourth heat treatment process, tempering. If hardened steel is too brittle, we use tempering. In tempering, the hardened steel is reheated to a temperature below the critical temperature and then cooled in air. This reduces brittleness while maintaining most of the hardness. Final result is a metal that's tougher, less brittle, and more reliable in service. It is commonly used in springs, gears, etc. Coming on to the case hardening. This process, unlike the other methods, doesn't harden the entire component. Instead, only the outer surface is hardened while the core remains soft and tough. The component is heated in carbon or nitrogen rich environment and then quenched. It gives us hard wear resistant surface and tough inner core. It is used in gears, camshafts, automobile components, etc. Now, let's have a quick recap. Annealing softens the metal. Normalizing makes the structure stronger and more uniform. Hardening produces maximum hardness. Tempering reduces brittleness after hardening. And case hardening, the surface is made hard with a tough core. So it is hard outside and soft inside. If you can remember their purpose, heating method, cooling method, result, and applications, you will be able to compare them easily. Thanks for watching.